A computer can get data input directly from keyboard or through files or directly from the internet in real time. To begin with, let us see how MATLAB accesses data input from keyboard. It is through the input function. Let's write a MATLAB script that uses input function in MATLAB to get the user input from keyboard. I'm starting off with writing some documentation, couple of comments that describe the author as well as what this script does. Now here is the line of code that prompts the user to enter a number, and when the user enters the number, it's going to be stored in the variable number. Now let me save this script and name it like input example. I'm gonna run it. So if I enter a number, let's say 1791. Okay, so you see that the variable number is populated with 1791. Now let me write another line of code that prompts the user to enter a vector. Now let me comment out the previous line. Okay, so this time it's only prompting me to enter a vector. There you go. Now I have a variable vector with the entered values. Let's go a little bit further. So I'm gonna try to enter a matrix. Enter a matrix, ones, 3. So it's gonna create a 3 by 3 matrix of ones, and that's the value of the variable matrix. Getting the user input as a string is a bit tricky. If you observe, I've used quotes while entering the name. Let's see what happens if I don't use quotes. MATLAB is treating that string as a variable name. There's got to be a better way to accept string input from the user. In the input function, add a quote s stating that the input is a string. Now you can confidently enter strings without using the quotes. Now whatever documentation you have at the top of your script, that's going to show up when you ask for help. So if I say help input example, the first 2 lines are going to show up. All right, now let's talk about the 2 output functions that display output on the MATLAB command prompt. So this code prompts the user to enter a number. Once the number is entered, we're going to display it back. Pretty simple. Disp displays the number. Now let's go a little further and then introduce some kind of formatting when we're trying to display our output. That can be done using the function fprintf. I'm going to get back to what I've written there shortly, but let's see how this program behaves now. Okay, so when I enter a number, the program is getting back to me saying you entered so and so. /n is a new line character. If I don't include it in my fprintf statement, you see that the command prompt is in the same line as the output line. Now let me add it back so that the command prompt goes to the next line. Instead of %d, let me use %f. You see that the new decimal notation showed up. Well, I have to admit that there are lots of formatting options in MATLAB. So this is the whole documentation. We have just touched %d is mainly used for displaying integers and %f for fixed point notation, including decimal values as well. Let's try more examples. Okay, so if I enter the number pi, it's showing me up to 6 decimal points. Now let's see how to cut short my output to just 4 decimal places. So I could use %.4f and then it's going to round it off to 4 decimal places. So let me show you how to do it for 2 decimal places. It's 0.2 2f. So now if I enter pi, it's just going to show 3.14. All right. You can keep repeating this. So 0.10f is going to show you like 10 values after the decimal point. Let's get back to integers. Okay, so if I say 42, it displays 42. If I want to add more spaces while I display this integer, I could do this. So I'm saying %10d. It's going to allocate 10 spaces in which that number is going to be displayed. Okay, so those are 10 spaces. We can validate them by filling them with zeros. The way you fill those spaces with zeros is by having 0 up there. So %0 10d adds like these zeros in those blank spaces. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 spaces in which we have padded zeros as well as the number 42. All right, so let's try to extend the same thing for the pi value, which has even like decimal values. Okay, so let's try to change it over to 0, 1, 0 point, let's do 4f. Let me give the number as pi. As you can see, again, we have 10 spaces in which the empty spaces are padded with zeros, but you have to see that 3.1416. So even the dot is considered as a space. The only way to gain confidence about formatting is by looking at plenty of examples.